Welcome, everyone. Um, Welcome to this quickie about visualizing Mandelbrot fractals using Project Riff and Spring Cloud Function. So it's a quickie, so it's going to be quick. We're going to see a lot of stuff. It's going to go pretty fast. I'm going to have to turn off that screensaver or just touch it a lot. So who of you does not know about Kubernetes? Good, because otherwise it would go really fast for you. So we'll just do a quick recap of basically what Ray Tsang told us in his talk on Monday and yesterday, and Burr Sutter gave a great talk about Kubernetes on Monday as well, so you can have a look at those. They really explain really well what Kubernetes is about and what the other technologies that I'll talk about is about. So my name is Dieter Hubau. I work at Ordina, Belgium in the JWorks business unit. So we mainly do Java, JavaScript, and cloud stuff. My GitHub credentials are there, and we also have a tech blog with some really interesting stuff. So let's dive into Kubernetes. As most of you know, I didn't see anyone's hand, so most of you know Kubernetes is a container orchestration platform. It enables service discovery for your applications. It can do load balancing using deployments and then load balancing over the different pods of an application, different instances. It can do automatic rollouts and rollbacks using the deployments. It has secret configuration, a secret management, configuration management. It can self-heal using the desired state of a replication, for example. It can always have a certain amount of pods running. And it can do horizontal auto-scaling automatically using CPU information, for example. So that's very short about Kubernetes. Go to the other talks or watch the talks on YouTube from Ray Tsang or Burr Sutter to have more information. Then, on top of Kubernetes and other platforms, we have a new technology called Istio, which is basically a service mesh. There's been a lot of hype around service meshes, and it's basically service mesh solves most of your cross-cutting problems or concerns that you needed to solve yourself beforehand. So it can, for example, do traffic management for you. It can route requests to certain versions of your application. It can do A/B. It can enable A/B testing. It can enable canary testing. It, for example, also secures communication between your services and uses can enable mutual SSL. It can, using the Envoy proxy, it can also do tracing, distributed tracing between your applications so that you can really trace the requests going through your environment. And it enables monitoring and logging capabilities for your environment. So really quickly, let's go to Knative, which is the newest part of this technology stack. It's building on top of Kubernetes and Istio, and it basically has three main building blocks for enabling you to have serverless workloads, to run serverless workloads. So everyone knows serverless, they're still, of course, servers in the background, just you don't care about them. So we'll see how they do that. It's split up in three areas. They have a part called serving, and they define their own custom resources in Kubernetes. So they extend Kubernetes. More about that in Ray Tsang's talk. And they allow for mutable configuration. So you can change the configuration of an app, and configuration is mutable. Each configuration change creates a revision, which is immutable. So revision is like version 1, version 2, version 3. You can switch between the revisions, and you can also route A/B test, canary test between revisions. And it also allows for automatic scaling from 0 to n. So not just from 1 to n, but from 0 to n. So if there's no traffic, it can automatically scale down your workloads to 0. Then we have the build part of Knative. The build part is basically it has two big concepts called builds and build templates. A build uses different steps. Each step can have a builder, and a builder builds your application. So lots of builds. But basically, it checks out your source code. It uses the builds to build your source code in different steps. It runs everything runs in containers still, and it can output an image which can then run in your in the serving part of Knative. So the build templates you can build yourself. There's different build templates for Hazel, for Jib. Jib is a cool tool to build your own Docker images without using Docker. They have some other tool sets which I can't remember now, but there's different build templates that you can create yourself if you have a custom build, and they're really easy to extend. The third part of Knative is the eventing part. That's quite interesting. They define some powerful new primitives to connect sources or event sources to consumers. So basically publishers, consumers, everyone knows the concept. They call them channels. So you can create channels on a certain bus, and on a channel you can do a subscription. You can create a subscription on a channel, which is basically defining a consumer. And you can redirect applications that pull from one or consume from one channel and output to another channel. The channels have usually a bus implementation. For the moment, we have a stub implementation, which just does in-memory eventing over HTTP. There's a GCP pubsub implementation, and there's also a Kafka implementation. So there's different kinds of middleware coming up that are able to act as channels. And basically, this Knative eventing allows you to also already publish events without the consumer is running. So the consumer can be at 0 instances. You send some events to a channel. It detects that there are events. It scales up the function to 1 or more instances, and it starts handling of consuming those events. So that's a really handy feature. Then again, on top of Riff, on top of Knative, we have Riff, which is something developed by Pivotal. And Riff is basically a short for Riff is for functions. So it's self-explanatory thing. And Riff is basically an event-driven function as a service. And it's very opinionated. And it is a layer on top of Kubernetes, Istio, and Knative. And it basically is the same as the inversion of control in Spring, that in that way that it allows you to define your logic as a function, and Riff and Knative and Istio and Kubernetes will handle the rest for you. So that's the idea. And the idea is also that you can run or create a function in whatever language you choose. So that's the power of Riff. Riff was announced last year at Spring 1 in December, and it basically did the eventing part itself. It also did the build part itself. But since July or August, Google announced Knative, which does those parts as well. They worked really hard together during this year. And basically, Knative is taking over the build part and the eventing part. And Riff is mainly focusing on creating a really good CLI for creating all these primitives. And also, they create a lot of invokers. So invokers is something quite interesting. An invoker is a piece of software that invokes your function, but for every language you can have an invoker. So there's a Java invoker, there can be a Spring Boot invoker, there can be a Node.js invoker. The power of that is that you just provide your function code without any dependencies even, and if you choose the correct invoker, it can build a wrapper around your function, put that in a container, put that in a pod together with the Istio sidecar containers, and run it as a workload on Kubernetes. So this is, for example, a way of creating the different primitives in Riff. You would create a function with Riff function create, add the invoker, add the name of the function, and then some arguments, like an image or whatever. You have many different options of creating functions. There's also a Riff service. So if you don't want to create a function, but you just still want to create a service, which is a Knative service, not the same as an Istio service, not the same as a Kubernetes service. So it gets quite confusing sometimes. But a Knative service makes sure that the scaling works and that the Istio sidecar containers are in place and that everything just works together. So if you create a service, it's like basically passing an image, and it will run that image as a Knative service. And then there's the abstractions for channels and subscriptions. So you would create a channel, give it a name, and give it a cluster bus. So basically GCP pubsub, that stub bus, or Kafka, for example. And after you have the channels, you can create subscriptions on those channels, define the consumer, and define the reply channel. So this is how you can hook all these functions together. So if this all is a bit vague, I have a good quote on that from Dijkstra. He was a Dutch scientist who created the Dijkstra algorithm for finding the shortest path in directed graphs. So he was quite a smart guy. And he said that the purpose of abstraction is not to be vague, so I don't want to be vague, but it's I want to create a new semantic level in which I can be absolutely precise. So if you don't understand what I'm saying, you're just not on my semantic level yet. Just get on my level. Another one, a really good one, is the entire history of software engineering is that of the rise in level of abstraction. I think that most of you will experience this as well. It's all getting, on the one hand, it's all getting more complex because you're building layer on top of layer on top of layer. But eventually, if it works well, you just have to write a function or write some code, and there's so many things that's done for you. So really, we're building on top of the shoulder of giants. So I have a use case. Most people are here for seeing the cool Mandelbrot pictures. I hope there's not a big anticlimax in the end, because it can get quite compute intensive, as you know. Most people are known, or the older people might be familiar with Mandelbrots as that piece of software you could run and you could build really cool images to put on your background or something on your desktop. And you could zoom in infinitely and your PC would go slower and slower. Some kind of old Pentium would really produce a lot of heat building those images. So we will try to create a Mandelbrot visualizer using Kubernetes, Knative, Istio, Riff, and Spring Cloud Function. So what is the Mandelbrot set for the people that don't know? It's considered to be one of the most complicated objects in the mathematics, but it is defined by a really simple function. So what you do is you have a grid, like a pixel grid of an image, and for each x and y value you have the x is a real value and the y is the imaginary value, so it's an irreal, if you call it that way, object. And you iterate over this function as many times as you can until it goes out of bounds. So if it becomes bigger than 2, it's out of the Mandelbrot set. So it really, it's interesting if you see inside of the Mandelbrot set, everything converges, stays below 2, and everything outside of the set goes really quickly bigger than 2. And all the interesting stuff happens around the edges. So the edges of the Mandelbrot fractal is where all the fun happens, where you can zoom in and see all the cool images. Those are images from my holiday. This is basically a function. It might be more complex than it should because I'm using flux as input and output. But as you can see, it's just using a Java util function with a calculation as input and a colored pixel as output. So calculation is a x and y value and the depth it needs to iterate over. So the maximum depth is like 255 or something to have some really nice colors, which I don't have, but it's black and white. The function mainly implements the function I showed before. So it tries to do z squared plus c and iterates over that until it's over the bounds of 2. If it's not over the bounds, then it returns the number of iterations it went through. So we wrap this function using Riff. We just do Riff function create Java Mandelbrot. It will wrap it into a Spring Boot invoker, and then we build a Docker container out of it. Well, Riff will build a Docker container out of it in Knative. That Docker image will be run in a pod which has these Istio proxies. So there's an Istio proxy and there's a Q proxy. 2 sidecar containers inside of that pod. That pod can then scale horizontally without a problem from 0 to n. And if we build more functions, you can hook them together. So I have one web application, which is a regular Riff service. And I have a calculation function and my Mandelbrot function. So the calculation function takes in a grid of x, y, width, length, something like that. And it basically sends it to the Mandelbrot, which calculates each pixel. So if you want to use the channels, we would send the first one to the grids. There's usually only one in the beginning. I just sent one calculation, one big grid. and then it sends it downstream to all the calculations channel, and then it sends all the results in the results channel. Here's some more information about the things I talked about, and let's show the demo, which is over here. Let's hope the function spins up fast enough. Not because it's Java. Well, it is because it's Java, but if it doesn't, I'll have to wait a bit longer. Patience is a great virtue. So in the beginning, so what it is doing now is it's sending line by line. So it's a 400 by 400 image. It's not that big, but that means there's 160,000 pixels to calculate. In the beginning, I usually have some, I don't know, noise of events that don't go through my WebSocket. So it's sending over WebSocket every pixel and every result of the pixel. It's just black and white, but it's in gray values. So if you wait a bit longer, because that's the final part of the demo, if you wait a bit longer, I can zoom in and show you some details in the gray areas. But basically, this is sending 160,000 pixels over WebSocket. It's not meant to be performant. It's meant to just show what you can do with a simple function. You just chain all these function calls together and just call this function a bazillion times. I had to put a little bit of delay in each column because otherwise I would have too many open web requests if the function took too long to spin up. So this is basically the Mandelbrot image. I think it's from -2 to +2, and on the top as well, -2 to +2. So that's the range of the entire set. Oh, it's filling up the other ones, see? Those are some leftover web requests that got filled in right now. So if I zoom in a little bit, you can actually see there's gray areas. If you want, you can put every gray value, so from 0 to 255, you can put this gray area in a color, so you can map it to a color, but I didn't have any time for that. But basically, that's the end of the quickie. Thank you.